Hey!
Hello, I'm Daniel Ehrenberg. I wanted to talk about up-and-coming standards in JavaScript modules. So we have JavaScript modules natively in the web and Node.js, and I'm going to talk about 6 new features coming to standards, how standards work, and how to get involved. So Miani, this is a Hebrew language meetup. I wish I could speak more Hebrew, but I only remember a little bit from Hebrew school as a kid. So I'm Daniel Ehrenberg, or Little Dan on the internet. I'm a delegate in TC39, the JavaScript Standards Committee. Hawaii Shelley is Las Roquetas del Garraf, which is a small town in Catalonia near Barcelona. And here's our nice coastline. My work, Shelley, that was a word I didn't remember. I had to look it up. I work for Egalia, which is a free software consultancy based in Galicia in northwest Spain. And Egalia works on embedded Chromium and WebKit development, graphics and multimedia drivers, and many different web standards, including JavaScript and WebAssembly. I'm in the compiler subteam focusing on those. And we work on both standards and implementation. So we're a consultancy, and the work I'm going to talk about today was sponsored by Bloomberg with the famous Bloomberg terminals, which I believe are also developed in an office in Israel, and IO, the creators of AdBlock Plus. So a vision that underlies a lot of this work is a standard JavaScript language. If there's a way that you can have one JavaScript program that you write in the same way, both directly in a Node.js console or a DevTools console, the same standard language as you use with bundlers in production environments. So the current world of JavaScript, especially when it comes to modules, is, well, it's approaching this, but it's not quite how things work today. So as we add new features to JavaScript, the idea is to support them the same standard way across all these different ways that JavaScript runs. So this is already the case with the basics of JavaScript modules. For example, the web and Node.js support ES modules. So the basic thing of having export and import, you can run it in a browser, in a web page with script type equals module, and you can run it in Node.js just like that, just running a module. And these engines know how to parse and execute modules. It's not like the old days when you had to run Babel to get modules to work. So ES modules are standardized in ECMA TC39. ECMA is a standards committee that's part of ECMA is a standards committee, ECMA International. It's based in Geneva, and TC39 was the 39th technical committee inside of ECMA. We work in meetings, normally in person. Now they're just video calls, as well as GitHub. We have a 4-stage process for new language features. In stage 1, an idea is under discussion. In stage 2, we decide as a committee, we want to do this, and we have a first draft. At stage 3, there's a final draft, and it's ready to go for implementations. So before stage 3, we'll often have early prototype implementations, especially in transpilers and polyfills. And after stage 3, we'll have implementations that come to more conservative environments, like web browsers and TypeScript. And once something has 2 full implementations and tests, then we can promote it to stage 4, and it becomes part of the draft standard. So proposals in TC39 advance by consensus. The committee agrees, the committee comes to consensus on a proposal meeting the requirements for the next stage and being something that we want to add to JavaScript. So you can join TC39 by joining ECMA. We unfortunately don't have any member organizations from Israeli companies or organizations, and it would be great to get more involvement there. But whether you're a member or not, everyone can participate in GitHub. So TC39 JavaScript doesn't exist in a vacuum. I mean, in a way it does, because the JavaScript standard itself doesn't know how to do any input and output. Instead, they integrate with input and output by what we call host environments, such as HTML. So the HTML standard tells JavaScript how to import modules, how to load them by doing an HTTP GET command. So HTML is actually an integral part to how JavaScript modules work. The HTML standard is maintained by an organization called Whatwig, or actually it's a stretch to call Whatwig an organization because it's very kind of informally based, but it's in GitHub. It has all issues and pull requests in GitHub and no meetings. And just like TC39, everyone can participate on GitHub. The criteria to land a change is that it requires support from at least 2 browser engines and no strong opposition, as well as a good review by the HTML editors and tests, just like TC39 also requires tests. And at this point, unfortunately, we're left with only 3 browser engines standing: Chrome, Safari, and Firefox. So let's talk about these new features. So top level await. One thing that's a little bit annoying about async functions is that async await is that you have to put the await inside of an async function. With this feature, with JavaScript modules, you can use await outside of an async function. The semantics of this is that it means that loading the module is awaiting. So it's like running a module is like running a big async function. If you import modules that have an await at the top level, then it runs all the awaits from each of the different modules in parallel. And so this can be used to coordinate initialization. If you import something that awaits something, then that will run just once, and it will run before the things that come later in the module. But it will allow other kinds of initialization to happen in parallel. So this proposal is at stage 3 in TC39, and it's merged in HTML. There were 2 different parts to the specification. There are several implementations that are complete, more in progress, and some implementations actually know how to execute this code or transpile it away, whereas other implementations just know how to parse it and allow it through. There's a lot of different things in the JavaScript toolchain that have to have some kind of support for a language feature to really be usable everywhere. So every time we make a TC39 proposal, there's what we call an explainer or a README that describes the point of the proposal, the motivation, and at a high level, what it's about. They also have specification text. We use a markup language called ECMARKUP. It's sort of like HTML and Markdown put together. And we describe how exactly the specification changes. In addition, in HTML tests to nail down the details. And these pull requests make changes against the main HTML specification. And then HTML also, there's some automatic infrastructure to generate these nice diffs. So to make top level await happen, it requires designing the specification, outreaching to different stakeholders, and making tests at these different levels of the exact semantics and implementing it in different environments. Another feature coming is JSON modules. So Node.js has supported JSON modules that you can import for a long time. You can make it work with Webpack. The semantics that we decided on for the standard is that when you import JSON, you get one big JSON object in the default export rather than individual named exports, which is important because not all the JSON keys in the object could even be named exports. It doesn't really map. When we were thinking about how, when I say we, I mean in the web standards world, when JSON modules were proposed to be added to the web, Mozilla and Apple realized that there was a potential security problem. If you import a JSON module from some kind of less trusted source, you might expect that it would only be data. But if we had a normal import statement, then it would have just as much right to run code. So for JSON modules, we require that they have this assertion that they're asserting that they're JSON. So these assertions were generalized further to import assertions. So in every module import statement, there's sort of a key value pair that could list assertions. The only assertion we're defining right now is type, but more assertions could be defined later. They're built into the module loader. They're not that you can add your own assertions. And these are required for this security mitigation. But the end result is that JSON modules will be usable equally in all these different environments with this slightly more verbose syntax. And so this is in stage 3 in TC39 and out for review in HTML. And I'm excited about this effort. In addition to JSON modules, expect to see CSS and HTML modules coming, where CSS modules let you import a style sheet, which you can then apply to a shadow root for scoped CSS manipulation. And HTML modules may work for templating in a way that's built into the browser, templated components, though that's there's a bit more design work needed there. Another feature that we've been working on in standardization is module blocks. Module blocks let you run more JavaScript code in parallel. So to run a worker today, you can use web workers in the web, but also in Node.js now there's a worker library built in, and these use message passing to communicate. But the API for creating a worker is based on passing in a path. There's a modification to this API. You can specify that you want to import a module, but the module is still specified in another file. With module blocks, we can have an inline module so that to make a new worker, you don't need to make a new file. And this is exciting, at least to me, because for a lot of applications, it can be difficult to break things into multiple files. Sometimes people have libraries that are reused in different environments, and there's no clear way to break it into multiple files that could be deployed everywhere. And so a module block is a piece of code that's independent of a particular context. It could be used in the place where you define it, or it could also be used out in a worker. But workers don't share anything with the other with the place they were launched from. I mean, they share some structures, but they have a different JavaScript heap. Everything is very detached from one to the other. So it's important that there be no direct object references from one to the other. So module blocks give an independent piece of code that can be shared. That means that they don't close over anything. So they can't reference things that are outside of the module block. They can just import other modules or reference the global object. So fundamentally, with a module block, you can import it with dynamic import and then get the exports object, and then you can use it. You can see this example uses top level await, because if you're writing any little async await code, it's just natural to use await at the top level. So module blocks are now at stage 2. We just had a TC39 meeting last week, and the committee came to consensus on bringing module blocks to stage 2. And in TC39, one way that the committee could organize itself is the committee takes on pieces of work, and then just everybody works on it. We in TC39 have a champion model. So committee members can champion or lead the work on a proposal, and they're responsible for collecting everybody's feedback and responding to concerns and proposing pushing the proposal forward. So Surma, developer advocate at Google, is the champion of this proposal. So they have a README, they have spec text, the specification text. This is one of the requirements for stage 2. And one of the questions that people ask often is, can module blocks be the solution to bundling? Can module blocks let you bundle multiple JS modules into one file? Because when deploying JavaScript applications, it's necessary to use bundlers to get decent startup performance. So maybe this could work. We could have these two modules that count in uppercase. If you want to use them, then we could await and import them. So maybe it could work for bundling, but really it falls over pretty quickly, because then if you have a third module that wants to use both of them, it's just not going to work. When you try to import count or uppercase, it's a reference error because these module blocks do not close over anything. Actually, we want a different concept for bundling. For example, we could call this JavaScript module fragments. So, you have fragments or IDs in an HTML page addressed by these hashes. What if we had that for JavaScript modules as well? So these are all in, some particular file, and you could import these modules, these inline module fragments, by a URL that ends with a fragment. And that's this basic idea. It's a very early draft. I have not fully written it up, but I think if we want to move forward with bundling, which lots of people have seen JS module blocks are excited about, then we might want to do something like this. So it's a declarative way of putting multiple modules in one file, and it's based on these URL fragments or IDs. A big advantage is that it avoids the need for a fetch, for an extra HTTP GET every time you want to get a new module, and it can all be understood by the JavaScript engine. But really, if you think about bundling, there's more to it. For example, you want to bundle in CSS or images or fonts, and tools like Webpack know how to convert all of these to strings or to base 64 strings that you could put in your JavaScript, which has some serious efficiency problems. But there's a lot more that bundlers do, like code splitting, figuring out the dependency graph for your program. And when some resources are not needed immediately at startup, maybe they're needed only when you go to a specific route, then they can be downloaded later. But still, the stuff that's downloaded later is in a certain limited number of chunks, rather than having to download each resource one by one. Another important function is cache busting. So making sure that you can use long-lived caching modes, but at the same time, when you have a change, you can address that new resource. It's also important to make good use of the browser cache. So if you have a JavaScript, one of these compound files, but only one part of it changes and the other part doesn't, then you would be kind of out of luck for the cache. But it would be great if the caching could be somehow more fine-grained to reuse existing things that didn't change. But at the same time, bundlers are very important because they help with compression. They help high-quality compression be used because the same dictionary can be used across the different resources that are together in the same bundle. So a more complete solution that I've been working on is resource bundle loading. So a resource bundle is a map from paths to a metadata and payload. So this metadata can be used to represent MIME types for different kinds of resources, and the payload can be a response body completely in binary. This mapping is defined using a language called CBOR, which is a way of encoding binary data structures that is used heavily in IETF-based standards. So to load a resource bundle, I'm suggesting that we use a kind of manifest that would be generated by tools to map different resources to chunk IDs. And so then when the chunk ID is loaded in the page, the browser knows, when one of these URLs is loaded in the page, the browser knows, oh, this comes from a resource bundle, and I need to load those chunk IDs. So in this example, the manifest says that, well, this CSS file, when I want to load this CSS file, it's in this chunk ID. And then when I want to import these things dynamically, well, I need those two different chunk IDs. And then these chunks on the server contain these different resources. So on the initial load, the only thing that's needed initially is, button.css and page.css. So the browser loads this chunk for page CSS, and the response actually has button CSS in it also. So that also can get used from the bundle. And that's what's loaded initially. When another resource is needed, when you import A, then it says, okay, I need these two chunks, and it can fetch those both at once. And then when B is needed, this chunk is already in cache, so it only needs the other one. Then say the page updates. So say that our common.js is the only thing that changes from alert to console.log. So only one chunk changes. These contain a chunk list, which includes not just the thing with a.js, but also its dependency. And so these hashes can be allocated similarly to how e-tags or bundler created cache busting works today, where when the content changes, the chunk ID changes, and this chunk ID is not found in cache, so it's the only one that needs to be fetched, and only when something is clicked. At the same time, these chunks are allowed to contain multiple resources. For example, the page and button are in one single kind of chunk. So to compare JavaScript module fragments versus resource bundles, there's a number of different axes of differences. One is text-based. The module fragments are just part of the JavaScript grammar. So somehow it's easier to implement and integrate that into things. But binary bundles have other advantages, that they can support other types that couldn't be brought into the JavaScript grammar. They require some new tools, but then as a benefit, they get efficient random access. Another difference is at what level do we want to virtualize resources? So resource bundles, this general solution that works for loading CSS or images, they need to virtualize resources at a lower level, that what you could call the fetch or the network level. So it's more expressive, but it's also somewhat more expensive. Whereas JavaScript module fragments, by intercepting only JavaScript modules, could be cheaper in some way, but more limited. There's also a question of how caching works. Resource bundles are cached at this chunk ID level, whereas JavaScript module fragments are stored in the cache as a single resource, so not supporting this more fine-grained subsetting. And versioning with resource bundle chunk IDs, you could change the chunk ID to represent a new version of the resource, whereas JavaScript module fragments don't have their own mechanism for that, and it's necessary to have a different mechanism kind of on top or on the side, as today. There's no sort of built-in web mechanism for versioning. So there are many different trade-offs when we think about performance. If you think about individual resources versus bundles versus these two alternatives that I just mentioned, we could think about the waterfall. Like, when you load one resource, do you know the other resources, sub-resources referenced from it? Is it going to be sort of some rolling rapids, or is it going to be a straight down waterfall when you're looking at all the resources that get loaded? Hopefully the latter. There's this per resource overhead, like how much does it cost in the browser and in the server to load each thing? Emulation, with if you try to pretend that everything is JavaScript, that adds some emulation costs. Browsers have multiple processes inside of them, and that often determines the communication, and the overhead from that can determine the loading performance of pages. Compression I mentioned before. If you bundle more things together, then the compression can be higher quality. Also, if the browser can understand more of what's going on, it can enable more parallel processing. Bundlers today obscure a bit what's going on. They have JavaScript logic that puts in the different parts of the page. So some parts of the browser that work today in a streaming way don't work as well. So streaming, when browsers download a page, if they're able to understand what's going on, then they can start interpreting it even before the whole thing comes in. And I talked about code splitting and chunking. So if we look at these different alternatives, we can see these trade-offs. With waterfall, unless you use the right prefetch commands, which you can use but aren't always deployed, individual resources have a kind of worse waterfall than any of these bundling options. They also have more overhead per individual resource because you need to do an extra HTTP get. This is cheaper with HTTP 2 and 3, but still it ends up being important on large sites. Resource bundles remove some of the load, but not all of it. They still go through certain browser paths that would be expensive because they're intercepting at this lower fetch level. And this emulation cost is a real problem with certain ways that sites are deployed, whereas resource bundles may be able to eliminate that, and using individual resources is already optimal in terms of avoiding this emulation. So in the interest of time, I'll skip to the next slide. I want to mention that there's a tension in general between compression and caching. For compression, you want to load everything all together because then they can share the compression dictionary. With caching, you want caching to be at a fine granularity to avoid duplicate loads. So you want to be able to request just what you don't have in cache, but then have everything that you're requesting be compressed together. So resource bundles kind of get the best of both, because if we look back at examples like loading this, when we loaded A, these two chunks got loaded together. So they can be dynamically compressed together if they share some code, reducing the size over the wire. At the end of the day, I think we might want both proposals, both resource bundles and module fragments, because of this per resource overhead issue that we see with resource bundles. So the per resource overhead issue is kind of serious. It's kind of comes down to the core value of bundling, where bundling should be allowing us to bundle together many, many resources. But JavaScript modules in practice today seem to lead to the biggest blow up in this number of resources, where you see 10,000 or tens of thousands or more JavaScript modules, and then maybe you see hundreds at most of other kinds of resources. So it kind of makes sense to put special attention to optimizing the per resource overhead of that. The other thing is that JavaScript modules often break up into packages or components that make sense to cache together, whereas other things, maybe you want to break them down a little bit more for caching. So I think we might want both. We might want to have resource bundles that have module fragments inside of them. So I'm running out of time, but I want to mention that that privacy and the origin model are really top-level concerns here. So Brave published a blog post about web bundles being harmful to content blocking. And this has to do with a few different things. This has to do with the origin model, that it's important that the origin of the site represent something. It has to do with URL semantics, that the URL is not just the origin, but the things that come after the origin be somewhat meaningful. And so the requirement in this proposal is that when you use a resource bundle, the bundle contents should be named individually by URL, and it must be possible to fetch that URL individually by that same name and get the same result. And it's important that bundles don't form a tracking vector, and that content blocking, like ad blockers, still work with bundling. So I've been working with the help of engineers in Brave and IO to validate that the design of resource bundles maintains privacy goals and doesn't doesn't lead to these problems. It's very important to me that we maintain these things. So next steps are to develop module fragments and resource bundles, which are both very early stage proposals, and module fragments in TC39, which they're not even a proposal yet, and resource bundles in WICG, and eventually in WhatWig HTML. WICG is a home for early proposals in W3C that handles intellectual property matters. And in this process, it'll be really important to prototype with implementations before things ship. People always talk about HTTP2 push. HTTP2 push was supposed to solve a lot of these problems, but it kind of didn't. And maybe that was because people were too eager to ship it before testing. So I think it's really important that we test this in various environments before shipping. And it's a big project, and it's an early project, and if you want to get involved, I'd be very happy to hear from you. So yeah, I definitely encourage you all, if you have time and interest, to get involved in JavaScript standards. So the development, the real technical work is done online in GitHub. We have meetings to discuss things and get more feedback, but almost all the ways to contribute are through that. And it would be great to have help with coming up with ideas. TC39 has a forum for that purpose. Documenting use cases, working out details of specifications, writing specifications and texts and implementations. And yeah, it'd be great to work together here. So thank you.
Sorry, you can only hear me clapping. I think there were some comments. First of all, thank you very much. It was very interesting. The thing I like about TC39 is that as a JavaScript developer, I'm sure that if I would take a break from JavaScript 3 or 4 months, I would come back and I'll be like, what the hell is going on here? It's a new language, for sure.
Well,
yeah, we also have a proposal that made stage 1. I think Benji was involved. It's the regex escaping. It made stage 1 a few days ago. It's an Israeli, I think, proposal. so we are involved. We are involved.
Yeah, it's been great working with Benji over the years. We've known each other for a while, and but we've known Israeli companies that are members. Benji's contributing as an invited expert, kind of, I guess, or just as a person on GitHub, and yeah, it's great.
Yeah, I think there were some comments about Webpack and the violent stuff, but I don't
violent
think it's
stuff.
No, it's sorry. How did you call it? Vite?
Oh, Vite.
Yeah, this is Webpack, and people fear that Webpack is going down. My shoving is Vite. Anyway, thank you very much. Anyone has final questions or something? Okay. Well, thank you.
Thanks.
Thank you very much.
Yeah, there were a bunch of comments that I saw after the Q&A ended that were about, oh, I don't like this bundler, and oh, it's great for bundlers to go away. And I wanted to explain how resource bundles would relate to bundlers. I think we still would need a piece of software that creates the resource bundles, and that would be a bundler. It still has to do a lot of the same analysis. I think the bundlers that we have today could, my ideal would be that these bundlers could serve as outputting these new kinds of formats that would be sent to the browser. But the part that's really annoying about bundlers, one part is it takes a long time for them to run, and another part is it's hard to configure them. So I think configuration could really be improved a lot if we had more use of standards. If we had more defaults that we could all agree on, then you wouldn't have to configure as many things. And if we have more standard formats, then you don't have to spend as much time hooking up one thing to another thing. And these standards could allow more investment in high performance implementations like ES that now can just implement the standards. So hopefully that, just to explain how this relates to bundlers. I don't think it would mean that Webpack would go away, but you would have the option of using resource bundles with Webpack or with ESBuild or with whatever if they decide to implement.
Thank you so much, Dan. It's a real honor having you here. I hope you will see you here again, JavaScript Israel.
Oh, well, it's an honor to be here, and I hope to come to Israel someday once all the virus improves.